Okay, good morning, class. Let's continue from yesterday. So, yesterday we talked about concepts, constructs, and started on variables. And today we will elaborate on the topic of variables and to have a really deep understanding of what they are and what they can do, and more importantly, what we can do about them. At the same time, before we make an official start, let me know if you have any questions or suggestions about the clips that I made for the past two lectures. Um, do you like them? Do you dislike them? What do you think I can do better about them? Let me know. And of course, let me know if you have any questions about the content, um, or if you would like to seek for clarifications. You know how to reach me. Okay, let's continue. So, a quick review, um, just in case, we forget about what we talked about last time concepts. Concepts are words, right, are terms that summarizes the commonalities of a class of phenomena, right? We say dogs are four-legged animals that bark. So forelegs and barking are the common features of all dogs that we know. So dogs or dog is a concept. Constructs, they're also concepts, right? Concept is a broader sort of notion, whereas concepts is a subclass of concepts, right? So we have concepts here at the higher level of this hierarchy of no ideas, and then to move down the hierarchy, we have constructs, right? So we know that constructs are a type of concept because constructs are concepts specifically designed or invented for scientific purposes. Right? All right. So lastly, so for example, natural selection is the example that we used yesterday. It's not a concept or a term that we used that often in daily life. Rather, we mostly use it when we talk about biology um, or nowadays psychology. So natural selection is a specific type of concept that we call constructs. Lastly, variables. So variables can be a concept. And of course, it can also be a construct, right? We can say the number of tables, right? The number of tables is a variable, right? Of course, I mean, you know, households that differ in the number of tables they have, or income, right? Income is definitely a concept. It's not necessarily a construct because we do talk about income every day. Um, so income is also a variable, right? People they differ in how much they make, and of course each individual they also make different amount of money depending on their stages in their career. Uh, and of course, we talk about, for example, power is is a construct, right? It's a construct that we use very often in psychology and in sociology. And of course, we talked about this yesterday, right? Power can take on different values from not powerful at all to very powerful, right? So by using the scale, and once we start assigning numbers, assigning values to a construct, or once we start assigning values to a concept, we're turning constructs or concepts, or just loosely, we're turning concepts into variables. Okay? All right. And yesterday we are here talking about this formidability hypothesis, using it as an example illustrating the function of variables. So we say, we can turn power, aggressiveness, these two concepts or these two constructs into variables by assigning values to them. We can say someone is very powerful and someone is very aggressive, right? Versus someone is not powerful and someone is that person is not aggressive or you know not prone to anger at all, right? So once we're talking about different values of of concepts, we're speaking in the language of variables. So you know once we start talking about variables, then we can start to reformulate this hypothesis in a very concrete fashion, right? So previously we say that formidability hypothesis predicts that power will predict one's aggressiveness. So it's still a little bit abstract, but once we replace all the terms in that hypothesis with variables, strong, stronger, right? That this word itself implies change from strong to stronger. More prone to anger relative to less prone to anger, right? So immediately we're talking about this, or we're discussing this hypothesis in terms of variables, and that really makes everything more concrete. And it's always a sort of a good practice in science that the more concrete we can get to a question, the better chance we have to answer it um, correctly, right? Okay, so let's say now this is our hypothesis, the hypothesis that we'll be working with. My question for you at this point will be, assuming assuming that this hypothesis is correct, how could we visualize this hypothesis? Visualization is a very, very important technique in conducting science, not just social science, but all kinds of branches of sciences. Because visualization, visualizing hypotheses and visualizing data as well, as we'll see in a minute, will greatly facilitate our understanding of what we have. So, an important skill that I hope that all of us can master or start to learn is how we can draw out, using bar charts, using lines to plot the statement. Okay? All right, so I'll give you a little bit of hint since it's probably our first time to plot any hypothesis in our life. So, first of all, recall that we have two variables. One variable is a person's physical strength, right, representing how powerful the person is. And then we have a second variable that is how prone, how easy they will become angry. So that will be our second variable. Because we have two variables, we'll place them on this coordinate, right, that we should be very familiar with. That's, I think, from, high school math or junior high. I don't know. But we should not be very foreign to this idea, right? So by placing these two variables, one at each axis, right? This is an axis. This is a second axis. Usually we say this is the this is the y-axis, and this is the x-axis, right? X-axis. And usually, there's sort of convention that says if our hypothesis says A predicts, well, X predicts Y, or A predicts B, right? Or, X X is correlated with Y, or A correlates with B. We usually, let me emphasize, it's not a must, but we usually put X or A, the variable that we mentioned first, onto the x-axis, and we place the variable that we mentioned the second on the y-axis. There's really no reason why we should do this, and sometimes you will see people do exactly the opposite. So that's why I said it is a convention, right? Convention is something that we all agree upon, but there's no real reason why we should do this. So for the purpose of the class, let's follow this convention, right? We place the variable that we mentioned the first at the x-axis, and we place the variable that we mentioned the second on the y-axis. Okay, so now we have these two variables at the appropriate places on this coordinate. Now our question is, how do we visualize their relationship, right? We say that physical strength, that's our x. Well, if someone is stronger, that means if, we designate that this end of this axis denotes that someone is weak, right? This is weak. And this strong, right? At the same time, this is not angry. Well, my apology for my handwriting here. And this is very angry. Okay, so now we have designated the direction of our scales, right? So for both scales, it's, moving from small to large, from small to large, or from negative to positive. Well, however you describe it, right? So we know that if a value moves from this end of the scale to this end of the scale, that means, a person gets stronger and stronger. Similarly, if a value moves from this end of the continuum to this end of the continuum, that means a person becomes angrier and angrier. Okay? So now our hypothesis is that if a person is stronger, that person will be more prone to anger. If that's our hypothesis, what should we draw here so that this graph can represent or can visualize our hypothesis? Okay, I'll give you 2 seconds to think about it. 1 and 2. So many of you may have guessed we use a straight line, a upward tilting line, to represent this hypothesis, right? This line is shooting in this direction. Therefore, it means if we, randomly pick a point. Let's say randomly pick 2 points on this scale. Say this point 1 and this point 2, right? And we shall be able to immediately see why this line makes sense, because this line represents someone is about this much strong and about this much prone to anger. Whereas this point represents someone who is this much strong and this much prone to anger. So this is person 1, this person 2, and we can immediately see that if we move from point 1 to point 2, that suggests as people become stronger, right? As people become stronger, they will at the same time become more prone to anger. That's exactly what the formidability hypothesis says, right? You can say, well, Andrew, that's because you're designating that we move in this direction. How about we move in this direction? Will our conclusion still be the same? Well, that's a good question. So let's figure it out, right? So let's first of all write out the exact words of our hypothesis. Stronger, physicality leads to, more anger. So we just said if we move from this direction to this direction, right? So if we sort of imagine that this line starts from here and extends itself to here, then of course this line corresponds to our formidability hypothesis. But a question is, well, what if the line actually starts from here and it goes down to this point? In other words, what if it goes in the opposite direction? Would this line still represent this hypothesis? I think that's a very good question. And let's see whether this makes sense or not. The short answer is, no matter how in which direction you go, you can go in this direction, you can go in this direction. The answer is, it doesn't matter. It doesn't change how we interpret this line. This line, as it is, regardless which direction you go, will still represent this hypothesis, and here's why. Because when we say stronger physicality leads to, more anger, it's the same way to say, rephrase this sentence to say, if you are weaker, you will experience less anger. And these two hypotheses are exactly the same. So if that's the case, and it is the case, then we can say, well, if we go from this direction, right, in this direction, then essentially we're moving from point 2 or individual 2 to individual 1. And we're saying, well, as people become weaker, right, we're moving in this direction, they will at the same time be less prone to anger. So you see, when we interpret this line in this direction, it will correspond to this hypothesis. And if we interpret this line in the upward direction, we're talking about this hypothesis. And this hypothesis and this hypothesis are equivalent. So that means as long as the line is upward tilting, then it doesn't matter in which direction, upward or downward, we interpret this line represents the same hypothesis. Okay? Does that make sense? I hope it does. So that's probably the most easy visualization we have so far. That is, we use a straight line to represent a correlation or association between two variables. Okay, let me repeat that. We use a straight line to represent the correlation or association between these two variables. Okay, this is really the foundation of all visualization of data, or I should say the visualization of correlations. Okay, and later on we'll be talking about more complicated but more interesting, relationships among three variables. Once we have that, how do we visualize their relationships? Okay, but now let's start with this one, right? I hope we understand why this line makes sense. Good. So at this point, after we have sort of a basic understanding of what variables are and a basic understanding of how we can plot the association, or how we can plot how two variables are related to each other, we can start to talk about different types of variables. Because knowing the types of variables will help us to understand or visualize more complicated relationships among variables. Okay, it's a very important topic. So when we talk about different types of variables, there are two ways to think about the types. We can say, well, we can classify variables into different types. First of all, based on what values they take. Or we can classify variables into different types based on their use, right? What functions they have. So let's first of all talk about how we can classify variables based on the values they take. First of all, we have categorical variables. So categorical variables simply means, or simply refer to, variables that can only take discrete values. Examples include our biological sex, our race, our ethnicity, and in many cases, our party affiliation. So, let's say we use this variable as an example. Well, first of all, this is a variable because it can take two values, at least among humans. Among non-human animals, it's possible that they have a third sex. But anyway, we're talking about focusing on humans here. In most cases, 99.9% of the time, a person is either a male or a female. In other words, this variable biological sex can take two values. Now, these two values, we call them discrete values because they don't overlap. They are two separate entities. Let's call them this way. They are mutually exclusive, meaning you're either a male or a female. There's no middle ground. I mean, again, in 99.9% of the time, right? There's no overlap between these two values, and it doesn't make any sense at all to place these two values on any kind of scale. Right, this is scale. You could place male here and place female here, or you could place female here and place male here, but that doesn't make any sense. That doesn't mean anything, right? There's no way to place two discrete entities on any kind of scale or continuum that implies some kind of continuity. Because in nature, at least among humans, there's no way that you can move, well, unless you perform some procedure, right? But naturally, there's no way for humans to move in any kind of direction from one sex into a second sex. So in this sense, we say that these two values are discrete. They're discrete values. Now you may say, hang on, what about race? Certainly we have Caucasians, white people, and at the same time we have African Americans. So we have, African Americans here, right? Or Asian American, doesn't matter. What if a Caucasian mom, or a Caucasian person, a couple, they're from different races. One is Caucasian, the other is African American. They got married and they have a child, and that child is of mixed sex. Sorry, not mixed sex, mixed race. My apology here. Okay. So this kid here is mixed race. Now I say, aha, don't they have overlap here? Because this sort of the middle state, or middle state between a white person and an African American person. But still, right? Once we have this person right here, half white, half African American, there are still separate categories of people, right? Once this child is born, there's no way, genetically speaking, under the current state of science, that you can naturally move from a mixed race person into a Caucasian person or into an African American person, despite that you have one parent from this category and the other parent from that category, right? So again, these three values of this variable race, they are non-overlapping and they're non-continuous and they're mutually exclusive, right? You can claim that despite my mixed race ancestry, I consider myself as white. Well, that's a different matter. That's your self-perception. But genetically, you are different from a white person. So again, we call these values, discrete. Well, lastly, you can easily reason through our last example, right? Party affiliation. You're either Democrat or Republican, or in some cases you have independents. In most cases, on most issues, Democrats disagree with Republicans, with independents, in the middle, right? They're middle of the roaders. Again, these people, they're mutually exclusive, right? They're non-continuous, so they're discrete, right? So that's why we say that these variables are categorical variables. They have values, male, female, white, African Americans, Democrats, Republicans, that belong to different categories. That's why we call them categorical variables. Okay? Oops. Let me erase all my drawings here. Okay, so when I'm erasing my drawing here, I'm almost there. If we have categorical variables, then it sort of makes sense that we have what we call continuous variables. Continuous variables are also very easy to understand. It simply means, right, um, variables will refer to variables that will take values that will form a numerical continuum. So these variables, right, are in direct contrast to categorical variables in the sense that the values of these variables, they, very much overlap. They form a continuum. Okay? It makes sense, in other words, to place this variable on a scale and arrange their values in order. And in a very technical sense, all these values, they're so dense that you can imagine that different values are infinitely close to each other, right? So in this sense, we say they form a numerical continuum. Examples. Again, these are just some typical examples of continuous variables. I'm sure you can think of others, right? So income is a very typical, almost I would say a true continuous variable because we can easily arrange all the values of income on a continuum ranging from, you know, um, $0 to $0.001 all the way to 99.999 to $100, right? So you see 99.999 is very, very close to 100, but still it's not 100, right? So as we add more nines to this number, you will get infinitely closer to 100. In other words, these 2 points, 99.99999, is very, very close and almost touches upon the point that denotes 100. They're so close that we consider the space between these 2 points infinitely small, such that, you know, when these 2 points join by other points who are similarly very, very close to each other, all these points form sort of a continuous continuum, a continuous scale that does not have gaps, right? So in this sense, we say income is indeed a true continuous variables. Well, attitudes is an interesting case because you can easily say that attitudes actually are discrete variables because you will say, well, in my, conception, I think attitudes have only two variables. You either disagree with an issue or you agree with an issue. You are very correct if you think that way, right? Because disagree is definitely very different with agree, or disagreeing very different from agreeing, and definitely these two values are not overlapping. There's no way that these two overlap with each other and they're mutually exclusive. You cannot disagree and agree on the same issue at the same time. So you think about attitudes in this way, then of course you will categorize attitudes, into categorical variables. But for many reasons that we don't have time to discuss here, scientists they sort of think or treat attitudes similarly to how they treat income. They think, well, actually, our attitudes are also, you know, appropriate, can be appropriately placed on a continuum ranging from, let's say, 1, that is, I strongly disagree with an issue. 2, well, I start to sort of move in the direction of agreement, but still I quite firmly disagree. Now, 3, well, I only slightly disagree with this issue. 4, now have a neutral position. And once I get past 4 and move on to 5, I become slightly in agreement with an issue, and all the way to 7 that I very much agree or totally agree with, the issue. So in this sense, scientists think that, well, attitudes can probably be treated as a continuous variable, the way that we treat income, right? There are a lot of debates on this. You don't have to agree with me or agree with scientists on their way, on the way they treat attitudes. But I'm just telling you that it is possible. It is theoretically possible to think attitudes as a continuous variable. Well, physicality, the same case, right? You can say, well, I think physicality is a categorical variable because you're either weak or strong. But other people might disagree with you. They say, well, you can move from very, very weak to kind of weak to slightly weak to slightly strong and all the way to very, very, very strong. So in that sense, physicality is a continuous variable. It also works. It also makes sense, right? So, but anyway, right? That suggests, whether a variable is a continuous variable or a categorical variable. Sometimes, not always, depends on how we see them. For example, here you can never say that a biological sex is a continuous variable. It has to be categorical. Race, similarly, party affiliation, 99% of the time, you would not be able to, convince an editor by arguing that party affiliation is a continuous variable, right? So these are pretty much set, but there are cases in which there's room for argument, and that's part of just doing science. It's all natural. All right, actually, and we just went through this, right? Some variables can only be categorical, because there's no in between middle of the road state between the two values, but some variables can be either categorical or continuous for reasons we just discussed, right? If we treat physical strength, for example, as categorical, we'll say someone is either strong or weak. But if we treat it as a continuous variable, we can start to assign, numbers to them. 1 smaller than 2, 2 smaller than 3, and we imagine, right? We think as if people, they differ in very, very finite ways, in terms of their physical strength. All right, so that's just a cautionary note, so to speak. All right, so previously, just now, we talked about, variables in terms of their values and how we have different types of variables depending on what values they take. Now let's talk about, different types of variables depending on their function. So function simply means use, right? Once we say that, well, the function of a desk is to support, a person when when the person sits. We're talking about, its use. Similarly, right? We can describe variables depending on how we use them. So, the first kind of variable that we have, once we focus on their function, is predictor variables. As the name itself implies, right? Predictor variables are variables that predict another variable. In some cases, it also means that variables that would explain a second variable. Later on, we'll also talk about causality, right? Causal relationship. So in a causal relationship, we have cause and effect, right? We have we have cause, we have cause that results in some kind of effect. So we'll say that this will also be a predictor variable because that's the variable that predict the effect, or that's the variable that explains the effect, right? In terms of how the effect occurs, right? So you can imagine then if we have, predictive variables, then we'll also have outcome variables. So outcome variables, very straightforward, right? There are variables that are predicted, variables that are explained, or variables that represent effects. All right. Again, let me present to you or introduce you to some kind of convention here. Later on, we'll talk about different types of research designs. And actually, in lecture one, we talk about two different types of study designs with surveys, and we have experiments. So it turns out that when you are conducting a survey study, it is usually the case that you will use words like predictor and outcome variables, right? But in experiments, you will call predictor variables as independent variables, and you will call outcome variables dependent variables for reasons that we'll discuss later. But for now, just remember essentially, essentially, predictive variables and independent variables are the same thing. You can draw they're the same thing. And outcome variables essentially are dependent variables. They are again the same thing, right? They're just different terms or different concepts used in different contexts. So just bear in mind that difference here. Okay. Okay, so exercise time. I know we all love that. What I'm doing here. Oh, okay. The purpose of this exercise is to identify, from the following claims or sentences, which is the predictor variable and which is the outcome variable. Okay? So I'll give you a few seconds to think about it, or if you would like, right, you can hit pause this clip, and start to think about it. In each claim, in each sentence, there are two variables, and invariably there will be one predictor variable and one outcome variable, and your job is to identify which is which. Okay? Well, let me have some water. While you think about it. Okay? Alright, so let's imagine that you have paused the clip and you're ready. Because it's recording, it doesn't make sense for us to wait for too long, otherwise the file will become very big. Okay, so I'll give you now the answers. In the first sentence, level of income explains why some people are happier than others. The predictor variable, as I'm sure that all of you have no difficulty identifying, is level of income. That's predictor, right? Because we have the keyword here, level of income explains, right? Because the definition of a predictor variable is the variable that predicts, that explains, okay? So that's our predictor variable, and the outcome variable is happiness, right? That's our outcome variable. So our second sentence, excessive drinking negatively impacts health. So here the predicted variable is the amount of drinking, right? Because excessive is an adjective, it describes how much one drinks. So, this is the predictive variable, right? An outcome variable, of course, is the degree of health, how healthy you are. That's outcome. Easy. Lastly, GPA depends on how easy a subject is and students and how diligent you are, how hardworking you are. So here, this one is a little tricky, and I lied a little bit when I said, in each sentence there are only two variables, because here there are actually three variables. That's the first trick. The second trick is this sentence is framed differently from the previous two sentences. So that means you cannot simply, solve this problem by saying, oh, this word appeared first, so that must be the predictive variable. Well, if you think that way, you're wrong in this case, because this sentence obviously means what explains GPA, or what predicts GPA. It is the easiness of a subject. That predicts your GPA. At the same time, how diligent you are will explain whether you have a higher or lower GPA. So both easiness of a subject and diligence, these two are the two predictive variables here. And we have an outcome variable here. Okay? So be careful, right? Make sure you understand the definitions of outcome and predictive variables, and don't rush once you see questions like these on the exam, right? Make sure you understand what the sentence means and then make a decision. It's not very difficult, just, be careful. Okay? All right. Once we understand different types of variables, we can start to describe, with greater details, how they're related to each other. It turns out that the relationships between, BW means between, okay? So it turns out that, the relationships between two variables, or among multiple variables, there are also different ways to think about it. First of all, we can talk about the relationships between variables, to keep everything simple, right? We now, only talk about or consider situations that have two variables, right? So the first way to think about the relationships between two variables is to think about the shape of the relationship. That sounds a little weird at this moment, but it actually makes sense, right? Later on we'll see. And the second way to think about the relationships between two variables is to think about the direction of the relationships. Okay, so let's make sense of them. First of all, when we're once we talk about the relationships between two variables in terms of shape, we mean this. First of all, we can have linear relationships. That means we can use a straight line to describe how these two variables are related to each other. At the same time, if we say that there's a curvilinear relationship between two variables, we're saying that the two variables, well, the relationship between two variables is best described by a curved line, not a straight line. Okay? See, very straightforward. So linear relationship, if we return to our example, the formidability hypothesis, which describes the relationship between physical strength and how easy you're prone to anger. Previously we say that, it's obviously a linear relationship. Okay? Because the relationship between these two variables, variable 1, variable 2, right? The relationship between these two variables is described by a straight line. And when this line is shooting upward, right? When this line is shooting upward, we say that the two variables have a positive correlation, or variable 1 positively correlates with variable 2, or the correlation between the two variables is positive. Okay? And if we have positive relationships, then of course we have negative relationships. So if you see a line arranged like this between two variables, you will know that this line then denotes a linear negative relationship. It's linear because it's straight line. Oops. It's linear because, first of all, it's a straight line, right? It's negative because it's shooting in this way. But you ask, well, in what way, right? Now let's make sense of it. When we say a relationship is positive, a relationship between two variables is positive, we do not mean that this relationship is good. Positive here does not mean good. Instead, positive here means the values of the two variables are moving in the same direction. Okay? Let me repeat. When we say the relationship between two variables is positive, it means that the values of the two variables are moving in the same direction. That's very easy to see because, again, right, we can have 2 points, point 1, point 2. So if you move from point 1 to point 2, right, essentially you're moving point 1's physical strength from here to here. At the same time, you're moving proneness anger from this point to this point. See? The values of these two variables are moving in the same direction. Or if you go in this direction, it's the same, right? So you will see that now once we're moving from this point to this point, essentially we're moving from here on physical strength to here on physical strength. At the same time, we're moving from here on proneness to anger to here on proneness to anger. So, well, let me use a different color. There we go. Again, we are moving in the same direction. That's why we say this is a positive relationship. Okay? This one describes a negative relationship or negative correlation because exactly the values of these two variables, they move in opposite directions. How so? Well, let's make sense of it. Well, let's say we move in this direction. Okay? Again, we have 1 point, point 1, and point 2. So if we move from point 1 to point 2 in this way, then we're saying we're moving from here on physical strength to here on physical strength. Direction is from, well, let's say from weak to strong. Okay? From negative to positive. But as we're moving in this direction from point to point 2, we are moving on y-axis from here to here. We're becoming less angrier. In this case, we're moving from the positive end to the negative end. Whereas on the x-axis, we're moving from the negative end to the positive end. So these two arrows, they are in opposite directions. That's why this line describes a negative correlation. So let me repeat. When we say two variables, they have negative correlations, it means their values move in opposite directions. Here, moving from negative to positive, whereas here, moving from positive to negative, as we move from point 1 to point 2 on this line. Right? You can do the same by thinking, what if we move in this direction from point 2 to point 1? Can we still reach the same conclusion that this line represents a negative correlation? Right? I'll leave that to you. Okay, so that's positive correlation, that's negative relationship or correlation. Now, another question for you is, what if I want to describe a situation where this variable and this variable have no correlation at all? That means, how can I visualize, to use a straight line, to describe a situation where there's zero correlation between this variable and this variable? Oops, I gave the answer. The answer is a flat line that is parallel to x-axis. Why this makes sense, right? It's because, again, we can designate, 2 points on this line, point 1 and point 2. So again, we say, well, what if we are moving from point 1 to point 2? That means we're getting stronger and stronger, right? Let's say this weak, this strong, right? That means the value on one variable is changing as we move from point 1 to point 2. There's no question about that. But when the value on this axis is changing, the value on the y-axis remains at this point. There's no change because these two, well, we're only moving from this point to this point on a one-dimension line. There's no change in any, vertical direction or diagonal direction, right? There's no change here. or here. There's only change in this direction. So we can see, when we say two variables have zero correlations, right? It essentially means that the value of one variable will change, whereas the value of the second variable does not change. That's when we say the two variables have zero correlation, do not correlate with each other at all. So we use a parallel line or straight line that is parallel to the axis to describe this relationship. And you can say that it will be the same if we draw a line that's parallel to the y-axis. It's the same, right? So we have 2 points, point 1, point 2. In this case, as we move from point 1 to point 2, we observe change on this variable. But when we have change on this variable from here to here, we have no change at all on this variable. So again, this straight line will represent a case where we don't have any correlations. Okay? So now we can have a sort of a conclusion here. That is, even with the same shape, right? So all these three, relationships, they're all linear relationships, right? It's a linear, straight line, a straight line, a fourth straight line. So they're all linear relationships, but at the same time, these are different relationships because they describe, in this case, a positive correlation, in this case, a negative correlation, and in this case, no correlation. So that's why we say these linear relationships, they differ by directions. Okay? What I have here. Okay. So, we'll conclude this lecture on, verbal descriptions. How we verbally describe the linear relationships that we just, draw. So here we have a first example, right? If we say as income increases, people are sadder, right? So we can say, it's income, it's no money, lots of money. We have happiness here, right? We have sad, happy. So if we plot this relationship, it will be as income increases, people are sadder. So it's a line like this. So therefore, it's a negative relationship. People feel more lonely as they spend more time on Facebook. Right? So in this case, we say it's a positive correlation because this is time and this is loneliness, right? There's not lonely at all, there's very lonely. No time spent on Facebook, lots of time spent on Facebook. So it here says, okay, so I switch the place of these two variables, but they're the same, right? Whether I place time here or here, doesn't matter. Okay, so it says, well, people will feel more lonely. People will feel more lonely as they spend more time on Facebook. It's a line like this. So it's a positive correlation. Lastly, I believe, the less time you spend on studying, the lower GPA you will receive. What do you think? Is this a positive correlation or, sorry, a negative correlation? What do you think? The less time you spend on studying, lower GPA you have. Well, while you're thinking, let me, draw out the statement here. So it's time. This is loneliness. Lonely, lonely. Damn. Okay. Loneliness. Okay, so we said that it's like this. Okay, more time, more lonely. Okay, so now the less time you spend on studying, the lower GPA you receive. The correct answer is, oops, this is a positive correlation. Why, you would say? Well, because if we plot it, okay, this is time, this is GPA, right? The sentence said, the claim says, if you spend, well, let's say this less time, this more time, this low GPA, this high GPA, okay? The sentence says, if you spend less time on studying, you will have lower GPA. If you spend less time, you will have, sorry, my mistake. Yeah, well, no, I'm correct, right? So if you spend less time, you will have lower GPA compared to if you spend much more time, you have much more high GPA, less time, lower GPA. This line is exactly the same line as this one. So if this one is positive correlation, we have a positive correlation here as well. Okay? So we'll stop here today and make sure you understand, what we're talking about here, right? So in today's lecture, we elaborate on the definition of variables, right? And say that there are different types of variables. There are categorical variables whose values are discrete, and there are continuous variables whose values are, whose values form a continuum. And then we have, predictor variables that predicts another variable, and we have outcome variables that are predicted by other variables. And then we looked at, the different relationships between variables. We have linear relationships, but we have different types of linear relationships. We have, linear positive relationships, and we have linear negative relationships. Okay. All right. So make sure you understand all these examples and the exercises that we had, on lecture. And of course, let me know if you have any questions at all. All right. So we'll continue tomorrow to talk about curvilinear linear relationships and much more on variables. See you tomorrow.